Alright, so welcome to 8-inch Reamer. I'm going to be reaming some machining content. I'm a fan of YouTube, and it used to be that YouTube was, you pointed a camera at a thing that you love, and you made YouTube films about it, and that was it. And then people started making money off YouTube, and it became more about making money than actually pointing a camera at the thing you enjoy. And a lot of what matters these days is making a beautiful thumbnail, and what's the other one? Oh yes, making your shots look beautiful. So I am going to be having a go at somebody who makes an awful lot of horrible mistakes, doesn't realise he's making an awful lot of horrible mistakes, and pushes it off as decent work. It's awful. On top of that, he's got a YouTube comments section which only has positive comments. Strange that. Yes, when you've only got positive comments, it's because you are editing those comments, generally speaking. So this guy is a guy called Fab Life, or calls himself Fab Life. He's a machining YouTuber. He wants to be an influencer. He's got about 10,000 subscribers. He's well into sucking the teat, and he's probably making at least half a salary off of this. He's got quite a lot of gear. He's got a Chinese round column mill. He's got a fairly big Chinese lathe, not a mini lathe. Bandsaw and various other bits and pieces. And yeah, so let's go. He's big into V4.
These are a set of cast iron V blocks that I'd purchased from Machinery House. Being that I'm pretty new to machining, I really didn't know what size to choose.
Shit, I'm still in fast forward mode. Let's reduce that a bit, shall we? I'm fast forwarding a lot of this because he films an awful lot of filler, and I'll go back to normal speed when he's talking. So, yeah.
And I fell into the trap of bigger is probably a safer bet. I soon found out that the 75mm option were mostly too big for anything I've needed V blocks for. As you can see in this 3D model of them, at 20.75mm, the round bar would have no pressure from the vice jaws. Also, when using the two together, anything under 36mm, I'll lose the ability to clamp the workpiece down. So just like any of my other videos, I was confident and convinced that I could save some money and create my own set of smaller V blocks. With some leftover 50x50mm square bar and over 5 hours of labour, I'm sure it was a better choice than buying a $66 set off Amazon.
Yes, it was. If you bought a $66 set off of Amazon, you would learn nothing, and you wouldn't get a video. You're going to get a second video as well out of making the clamps, aren't you? But no, for anybody, it's a much better idea to make your own. He's going to use cold rolled mild steel, which is not the best choice for this. Cast iron would be far better, but then that's a bit more tricky to get hold of, isn't it? Anyway, let's see where he goes, shall we? I've already seen, but hey.
Before tackling this project, I'd spent some time in Fusion 360 and modelled a version that I think would suit what I do.
Yes, of course you have. This model bears no resemblance, well, not much resemblance to the final result, so it's a waste of fucking time. But fills in a bit of space on the video, doesn't it?
Do as a hobby machinist. With all that said, I'll now remove a 90mm portion off this square bar and start the process of cleaning up all the faces.
90mm portion. Now, this is pretty much the only time he ever mentions a size. But anyway, right, here's a bandsaw. Bandsaw is a very good way of cutting stuff down. It's an extremely useful tool. Saw is by far the fastest way of removing material. Bandsaws are great. So, however, I am going to fast forward it because well, you'll see. 1.75 seems reasonable. we see setting it up, we see clamping it, we see turning it on.
If you're newly getting into machining, I highly suggest buying a length of 50mm square bar from your local metal supplier. I paid $80 for a 1 metre length of this, and I've used it on many projects with still having a heap left over.
Now, that's not a completely daft idea. You know, you should have been able to make that out. You can go and buy a chunk of steel like that, and it's, you know, it's kind of fun to work with. You're almost better off if there's an engineering workshop nearby. Go and asking if you can look around their bar ends. They'll probably give you chunks, you know, the leftovers basically. That's where all my stock comes from, pretty much. Yeah, but if you need a particular piece of steel, go and buy it. But yeah, mild steel's not the best stuff to be making stuff from, especially not hot wire.
I know this small chunk of metal doesn't look like much now, but after many hours of flicking hot metal chips everywhere, it'll soon transform into something very satisfying and useful in the shop. I'll now move on to facing all the sides so that the two V blocks are somewhat of a matched pair. Also,
Somewhat of a matched pair. No, if you're making a pair of V blocks, they're a pair. They are very matched. They're totally matched. Otherwise, they're useless. Now, I'm pointing at the screen. You noticed that his fly cutter, which he's going to use to do this, has been stamped with Fab Life. Isn't that nice?
I'm very keen to try out a new process that I've researched that's called a 1-2-3 method.
Right. This is the way of squaring a piece of stock using 1, 2, 3 orthogonal faces, and then putting your other faces parallel to those. So it's a good way of working. Let's see how he does.
I'm using my shop-made fly cutter, which leaves a great finish on the steel and can also...
Fly cutter's the wrong tool for it though. He's going to be pushing his fly cutter too hard to remove too much material, and when you come down to it, he's going to get a great finish on all of this, and then he's going to remove most of it because he's got to cut V's and grooves into everything.
Also face the entire surface in one pass. I have made this tool in a previous video if you'd like to go and check it out after fully watching this video, of course.
Did you hear that? Now, even at 1.75, that sounds pretty rough. That's because he's using a Chinese round column mill. He's pushing his fly cutter hard, and there's slack and it's pissy wobbly all over the place. But, you know, piss of the cock you got and all that.
So if you're unfamiliar with the 1-2-3...
That was the first piece of brushing that we've seen. It will not be the last. You'll also notice that his fly cutter doesn't leave a perfect finish. His head's slightly out of tram.
method. It starts with facing one side and labeling it number 1. I mean, you don't have to, but if you're like myself, I'll forget what is what and it will soon turn into the 1-3-2 method, resulting in a perfectly inaccurate set of V blocks. The key to this working is that face number 1 must always be against the fixed jaw of the vise. Secondly, you'll need a metal...
Yep, so face number 1 against the jaw of the vise. Put something in to help clamp, yep.
Rod to create a single point of contact to ensure face number 1 is pressing properly against the vise jaw. I'm using a TIG welding filler rod for aluminium welding.
See those sparks? That's because he's running his fly cutter too hard. Probably could have got some ahead on this by taking the scale off first. Dunk it in vinegar overnight. Now you'll notice that's caused by vibration. Whoops. That little circle there, that's vibration in the ways. Something has sparked a bit more, and yeah, you'll notice that all the curves go the other way. That's because his head is tilted slightly out of tram, so it's the back. It's cutting more on the back than on the front. But there you go. That's face number 2. Now, face number 3 has to be orthogonal to face number 1 and face number 2. Deburr, that's good.
Now that face number 2 has been machined, it now points to the bottom of the vise, and face number 1 is still placed against the fixed jaw.
No, that's not orthogonal.
My mill comes with a plastic shield, but because I'm dedicated to getting the best angles and close-ups of the machining process, this is what I need to do sometimes to protect myself from the burning hot chips that want to go all over my arms.
Oh, you poor dear. Oh, that lasted a long time, didn't it? Minge. This is your job, mate. Either you use a shield or you don't. Don't fucking moan about it, and don't pretend to be doing something that clearly doesn't work. You've noticed the little pause causes a nice little scrape on the surface. It's because it's vibrating. Nothing major.
Here is the aftermath of using this fly cutter. Of course I have eye protection and earmuffs on. I could run the cutter the other way, but I find it sends the chip straight at the camera.
Right, it sends the chip straight at the camera. That's what zoom lenses are made for, you minge. And, you know, either you accept it or you put a shield up. It's not that hard. Little cardboard shield does the trick quite nicely. Thank you very much. And it doesn't get in the way of the camera. Remember, you're choosing to do this.
Before you jump in the comment section and tell me what I'm doing wrong, try having the company of a camera on a tripod with you the whole time.
There you go. You are choosing to do this. You're choosing to have a camera on a tripod all the time. And it is a pain in the arse, especially when you're changing the shot every 15 seconds, which you seem to be doing.
With face number 3 all machined, the next step is pretty straightforward. The workpiece now will have all 3 faces.
Right, what you've got now is faces 2 and 3, which are parallel. And he's going to presumably mill this face here, which will give him 1 and 4 being parallel. And then how's he going to get 5 and 6 orthogonal? Oh dear, it's not going to work.
It's contacting the vise. I'm not sure how precise this will end up, but I'm sure it will be better than the other methods I've used that I basically guessed my way through.
Well, this is basically guessing your way through, you tit. Didn't knock it down. Never mind. Be alright. Jesus fucking nuts. You've got brave putting your fingers near that fly cutter too. Right, it's kind of squaring up with a 1, 2, 3 block. That's yeah, kind of all right way of doing it. It's not going to be accurate, but it's not far off. I'm guessing that the parallels to stop the piece of work dropping down in between the 2 slideways of the vise. Yeah. Riding that badly up there, isn't it? Brushy, brush. Not clean, but, you know, hey. Not knocking anything down. Right, at this point, he shouldn't need to use the 1, 2, 3 block. It's a reasonable check, I suppose, but shouldn't need to use it. If it's out of square, it's because your cut on the first face there was wrong. I think I should use them anyway.
With all 6 faces machined, I wanted to use a radius cutter to round over the edges for a more professional finish, but after
a more professional finish. You're not in the finishing stages at the moment, you're roughing. And a V-block doesn't need radiuses. It needs you to just file the corners to stop them burring over if you knock them.
But looking at the result, I decided to go with a chamfer instead.
Now that's a reasonable approach. What he's doing here is he's going to get him the same chamfer on all 8 of those edges, because he's got his chamfer cutter set at a particular height. So he's got his Y and X locked off, and he's just going to not Y and X, his Y and Z locked off, and he's only moving in X. And he's doing conventional milling with it, which is good because his mill is not rigid enough to deal with climb milling. But he's getting a fairly lousy finish. Yeah, it's okay, you know, who cares? And that's a very, very fat chamfer. Now that's a bit of a dodgy one. He should have left his parallel in between the vice jaws, and done it that way. He's not clamping on the full width of the vice jaws. It's not the best way to go. And you'll notice his cutter's cutting on the way back as well as on the way out. That is because of flex. It's a one-tooth cutter, so as it hits the work, it's being pushed kind of obliquely back to the right, which means that its next impact is obliquely back to the right, and it's slightly off. You get the head will nod slightly, and the whole thing fucking flexes. I mean, they're terrible. These Chinese mills, terrible, fairly terrible. And so when he comes back, he's still contacting, he's still cutting. He's probably cutting about as much as he should be cutting with a single flute cutter on the way back. But because he's whizzing it back, that's not helping his surface finish either. So that's his ends chamfered. They really are very fat chamfers. I don't like those, but hey, I guess he had to cover up his round over thing. Now his problem is going to be that although he's good in the Y-axis, he needs to get the Z-axis correct to get the same chamfers on these edges. And then he's going to have to work even harder to get the chamfers on the rest of the edges when he eventually cuts this thing in two. This is why you do the chamfering at the end, if you're going to do chamfering. You'll also notice that he hasn't really measured anything as far as I can tell. He doesn't seem to have hit any particular, he doesn't seem to have said, right, okay, I'm going to start with 50 mil, I'm going to go for 48 and measure everything. But, we'll assume that he has measured, shall we?
Never in my life have I paid attention to how many edges are on things. Now that I've taken...
Yeah, well, there's lots of them, aren't there? There's what? 8, 9, 10, 11, 12 on that. 6 faces, 12 edges.
In a deep dive into hobby machining, I'm now haunted by how many of the same process there is on something that has many edges. Chamfering is a...
Yes. Yes, there are lots and lots of repeated things going on in machining. It's the nature of the beast.
Apparently something that separates us from the animals. A wise woman...
Oh dear. Okay, if you missed that one, let's go back, shall we? And let him say it.
daunted by how many of the same process there is on something that has many edges. Chamfering is apparently something that separates us from the animals, a wise woman has continually said. So this is why I chose to do so on this project.
Right, using somebody else's catchphrase, that's pretty tedious, isn't it? That is a Quinn Dunkey catchphrase. Quinn from Blondie Hacks, if you don't know, I'm sure you do. Quinn does reasonable work, very good work in a lot of times. I feel kind of dirty watching her videos because you know that there's a whole bunch of sad old gits beating one off to them. This guy wants to be Blondie Hacks, I guess, but he's never going to be Blondie Hacks because he's not got the tits. You're not going to get the simping. You have to do it some other way. Maybe you could try doing decent work. So you were doing all right. You were going to have 4 perfectly equal chamfers on those edges, but you've just moved the quill. I saw you do it. Watch. That's because his first chamfer wasn't deep enough. So you'll now have 3 chamfers that are one size and one that's another.
Almost 12 minutes into the video, and now we have ourselves a nicely machined rectangular prism.
Well, rectangular, I'll give you that more or less. Prism remains to be seen. Haven't seen any measuring going on. I'd like to see a micrometer. Saw a very good video yesterday of a guy who was trying to make some 1-inch cubes to within a particular tolerance of 1 thou. A very, very good video from, I think it was Dee's Workshop, guy who admits his own errors. I'm willing to bet that these are nowhere near square.
I apologise if I've made some of you fall asleep with boredom, but this video is a fairly true representation of what it actually takes to make this project. I mean,
Yeah, it probably is.
could always not speed up the clips and release a 2.5-hour version of this same video, but I'm sure the retention rate will be terrible. Next up, I'll mark the depth of the V portion, and also how much will remain on the edge. The lines are only for guidance, so that I know...
Right, so I'm assuming that he has done some measuring. Although, actually, hang on, let's have a look. That's at exactly 20 millimeters. Okay, he wants to go 20 millimeters deep. All right.
when I'm close to the target dimensions.
Right, target dimensions. Now, he's talked about dimensions here. That's good. So presumably he knows what he's aiming for. Good. You don't scribe twice, though, and you don't need to push that hard. When your scriber's bending, you're pushing too hard, especially if you're scribing into, die chem or marker. Not after doing half the cutting work with the scriber. Right. Notice that he marked the full length, but then he only scribed the length of his marking tool. That's a bit peculiar. Now here he looks to be going for the centre mark, and if we look here, we are at 24 point. Yeah, go away. Go away, YouTube bar. 24 point something, about 24.2 maybe. Oh no, hang on. 24.6, I would say, thereabouts on the vernier. So that's his presumable centre line.
To get the 45-degree angle, I'll be using a digital angle finder. Each time the angle finder...
You what? A digital angle finder. Yeah, okay.
comes out, it's a reminder that I still need to buy a set of precision angle blocks.
Right, if we go back to the beginning of the video, you will find that you've got a pair of precision 45-degree angle blocks, which you've paid good money for, and which would be perfectly suited for this job. Perfectly suited. You don't actually need to go and buy precision angle blocks for any angle anyway. If you go and look at John's workshop, a channel, he has a thing called the angle set, which is basically a piece of plate with some pins put into it that allows you to set specific angles. But if you've got a DRO and you're capable of, turning your handles until you meet a zero, you can use trigonometry to make one for any arbitrary angle you like, or any number of arbitrary angles you like. The precision pins that John uses are precision ground gauge pins, I think, if I remember correctly. All of mine use old rollers from roller bearings. They're perfectly good. It makes setting up, for example, a Morse taper on the lathe a 15-second job as opposed to 3/4 of an hour trying to meet stuff with a tapping stuff with a hammer and running your indicator up and down things, and it's a great way of doing things, and it would work perfectly well here. But you've already got a 45-degree block. It would make your life an awful lot easier just to use one. This is less accurate than the average builder's level. Normally they're pretty accurate at 0 and at 90, and then they're dog shit in between. It's nowhere near a precision level. A builder's level typically gives you an order of magnitude of about 0.5 millimeter over a millimeter for a given for level. So assuming you're getting 0.5 millimeter over a millimeter for level or for a particular angle, that's not that great. A real precision level is hundredths of a millimeter over a millimeter. Mine isn't terribly accurate. It's only 5/100ths of a millimeter over a meter. So, which means that if I put it on a piece of stock, every move of graduation on that of the bubble is 5/100ths of a millimeter lifted at one end of a meter of stock. So this is a piece of shit. You should throw it away and use your fucking V blocks. Well, that was fortuitous. That went in very easily. Oh, look at the state of those lovely, lovely chamfers. Oh, go on. You can hear it vibing already. Now, I don't see any marks particularly apart from his centre mark that he can go to, but I'm not looking at the right angle. So. Oh, that's even better. He's climb milling that. Now you'll notice that he's got his scribes at this end. If he's going to climb mill this from here, he's not going to be able to see whether he's meeting his lines or not. That said, he did say they were for indication only to give an idea of whether he was meeting the measurements he wanted. His target. God almighty, that's a deep cut. Now you see how much fun his mill's having. I'm assuming he's not moving X, but that's very, very, very wavily. I know that these leave a fucking shitty finish, but hey. Really shouldn't be coming. It's not made for conventional music. In any case, it's mild.
For reference, this is a high-speed steel 14mm roughing end mill. I had it running at 600 RPM, which worked amazingly well.
In any case, it's mild steel. You're going to get a shitty result anyway, whichever way you cut it. Brushy, brushy, brush. Brush, 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 brush. We need to see all that brushing. That wasn't very tight, was it? Do you think it might have vibrated a bit? Okay, is that cutter long enough? Bit of air, push the chips away, you get a decent finish there. Now, he tried to go to his line there, but he couldn't see it because he was coming in from the wrong end. So he may have hit it and he may not. Who knows? I'm waiting for him to try and climb cut that whole face. That's not going to vibrate at all. Go on.
I wasn't happy with the surface finish of the carbide.
Say what? Say what? You're going in with a fly cutter. Okay. So you're going to blow your dimensions. For the moment, his okay, well, he's gone not deep enough on this side for the moment because he's going to have to clean this side up to get his V to finish exactly here. Let's see how he does. Because I don't think with this fly cutter he's going to be able to get in there.
End mill, so I switched back to my fly cutter. The only downside was with the clearance when getting right into the V section. This won't be an issue as I will be machining a relief in the center later on in the video.
Okay. Not that. Okay, and you're going to take it out. Oh, well done. Oh, well done. Every time you take something out, you increase your inaccuracies. Especially when you're using a digital angle finder. Good Lord. You want to nip that up a bit, it's going to fall over. Tit. Oh, well, that went very easily as well, didn't it? And so you're going to fly cut that side as well. Okay. And from here, of course, you can't see your marks. Now, why is this important? Well, hang on, we'll come back to it in a second. Right, because he's going to slot it now, isn't he? Right, okay. So centrify that. Inside. Ooh, it's got a DRO as well. Right. Right, he has centered. Now, why it's important that this face and this face meet in the centre is because when he's cut this in half, there are 4 ways that he can put his angle blocks together. If we imagine that we're cut in the middle here, we've got one face here, one face here, one face here, and one face here. So you can put them together this way, and this face and this face will automatically line up because that's the way they were machined. If he takes this block and puts it over this end, as long as everything's square while he's machining, they should line up. I don't think they will, but they should line up. If he turns one of the blocks through 180 degrees, you've got this face meeting the face that's down here, and this face meeting the face that's here. And if they don't meet in the centre, your blocks are not centred, they're not the same. So if you're trying to support something in a vise, for example, you're going to be cocked. There's also the fact that they're probably not at 90 degrees, but that's as may be. So we'll see what happens as we machine, if we can see it. I don't know. Oh, right, okay, hang on, let's go back a couple of seconds. Right, I'm going to go slow here. So playback speed. 0.25 times. That should do us. Right. So what we've got here is the first cut is here. First touch off is on this face. And this face doesn't look to be touching yet. So hopefully, as we mill across, we'll see. Let's see what happens. Yeah, that looks deeper than that to me. Yeah, one side's deeper than the other. Ooh, that went in square. Why are you using your 1, 2, 3 block?
After a quick clearance check, I still needed to machine a little more off.
Ah, right, okay, he's checking to see whether he can get a V in there, a square in there. Strange that he didn't do that with his existing V blocks and these squares. He seems to have understood that you can get a square into a V block. All right, so that's one dimension fucked, isn't it? Biari. Oh, see the way that wobbled? Nice. Remember, this is a precision part.
This is the larger V side mostly complete. I'll now move on to the same process for the other side, but with a more shallow depth of cut for the V section.
Yeah, you can see it there. So this side is clearly longer than this side. This side is further up, so further in. It's not deep enough, basically. More of the same then. God almighty, he's pushing on that scribe. What are you doing here? So you're marking things out differently. That's good. So different technique. Okay, bring the At this point, if you wanted to make sure that you were at least parallel between the V's, you could put a, pointing at the screen, you could put a parallel in here and sit one of the V faces against it. You wouldn't need to piss about with your angle finder. Or you could put it in a V block, like you should. Oh, I thought for a second he was going for a 60-degree V, but obviously not. So that would have been funny, it would have been the wrong 60. Very slow as well. So right, same old, same old. But he's doing it differently because he's only marked one line and then he's marked 2 lines. Okay, never mind. Never mind, eh? Nothing like being consistent when you're machining. Oh, go on, boy. Oh, you've blown that, haven't you? Whoops. Prediction, he's going to be way further down than that. Keep going. I mean, it doesn't actually matter. It's just that, you know, he's missed his. Well, we don't know which scribe line is the right one anyway, but he's missed his intended dimension by a good millimetre. Quality machining. We haven't done any finishing yet, because presumably we're going to fly cut this. So, he's doing it with an end mill. Well, that's the best way to do it. Is he going to flip the part again? Or is he going to go for assuming that that is at exactly 45 degrees, so the other one will be? He's going to have different surface finishes, especially climb cutting with a cheap Chinese end mill on a cheap Chinese mill in mild steel, but hey, let's see what happens. Lift that end mill up. Oh, that's crafty. We can't see where he hit. So just one go. That's the way he should have done the other one. But if he'd have used his existing V blocks, he could have done it all in one setup. Well, each side all in one setup, you know, the V's, and he would have got them at 45 degrees, and he could have, you know, been a bit more careful and got them right to the centre. Find the centre again, because you don't trust the centre you set for the other side. Right. Okay, so he's going to groove this. Same old, same old. That's a good idea. There's an air in there. Yep. Oh, look at that. Look at that. He's got a nice cut on that side. He's not even touching here. Quality. May actually be that he's going down on one side and then coming back on the other though. So I'll give him the benefit of the doubt.
With the relief portions complete, I'll now machine an 8mm slot on both sides for the clamps to slot into.
Stop moving it around. Right, okay. That setup is fucked. This is your reference surface. That's your reference drawer on the vise. You want maximum clamping on there. That is barely touching on the top. So you're only clamping the bottom. If you flip your part over around with this bit against the moving jaw, you get far better clamping and far less vibration. Now we're going to centre fine. No, we're just going to assume that we're the same dimension. That's fair enough. Oh yes. Oh no, that was a bit ambitious, wasn't it? Get some air in there. Oh gosh. Ah, that's easy. Bit of air keeps the chips out. Getting a glorious finish in there. That is mild still. It's the realities of swap cutting mild steel or a cheap Chinese mill. It vibrates like a motherfucker. Oh, we've got to get those chamfers in there. Ah, yes. Fuck me, look at the state of that. Lovely, lovely. Not at all mullered. Okay. Go on, do the other side then. Bit more brushing. Oh, yeah, we need some more brushing. Oh, he nearly showed us where he hit the dimensions there, didn't he? Oh, look, touched off. It's not wandering at all. You can just see the vibration. Chewy, chewy.
We are finally getting close to being complete. Now for the scary task of cutting this in half. I'll now attempt this on my bandsaw.
Okay, well that's going to be difficult to hold. I hope you've got another piece of 50. You can put in the other side of the vise because that is going to, unless you're putting the bandsaw vertically and cutting it by hand, that is going to be interesting. Oh no, in the vise, okay. Bloody hell. Bloody hellfire. Right, he needs a piece of, go away. He needs a piece of 50mm stock in this side to keep the jaw from cocking. He needs a jack underneath it, and he needs it on its side so you can jack on something sensible. Because as it goes, you'll be really lucky if that doesn't pull it out. Because the downward pressure of the saw, unless you go really, really gently, is going to make this want to tilt this way, downwards. And as it tilts downwards, the little tiny bit that's held in that jaw is going to want to pull out, and then your piece comes out that way because the band is going this way. The piece comes out that way, and you snap the blade and fuck up your piece. And as long as you're lucky, you don't get a piece of band, saw band in the leg. But yeah, that's really fucking ropey. Hold on, didn't see him turn it on. How do we know it happened? Right, you saw it move very slightly as it came into the bottom of the groove. It's down here that things are going to get itchy, because you're going to start getting into the saw teeth cutting into the back end of this V. Okay, got lucky. That's, I wouldn't want to do that. Alright, put them both in together. Good man. Are you certain they're the same size? God, I hope so. I'm sure they are. Yeah, of course they are, Simon. And yeah, we can fly cut that. It's not like, you know, taking 0.5 millimetre off, is it? Oh, hang on. Okay, it's not doing it in one cut. Ooh, nice cut. Roughing with a fly cutter. Yeah? Right, previously when he was doing it, he was putting things in here, keeping things locked in X and Z, and only moving in Y and Z, and only moving X, so that you get the consistent chamfer. Here he's going to get random chamfers all the way around, and he's going to have two edges that he's going to have to pull out. Lovely. I think it's because he's bored, wants to get the video out. It's too much work to undo and redo the vice. What, 8 times? Do it all in one go, much more efficient. Fuck me, look at the size of those shelves. Yeah, you missed one there, didn't you? Yeah. Okay. And what are you going to do about those other 2 edges? You can do those? Yeah, of course you are. It's only a single tooth cutter. It's not like it induces an awful lot of vibration.
Alright guys, we are on the home stretch. I'd also like to ask a favour from you. I'm trying my very best to hit 10k subscribers this year. If you are feeling generous, I kindly ask you to hit that subscribe button. Over 80% of my watchers are not subscribed. Imagine if everyone was. My channel would get seen by a whole lot more people.
Yeah, that'd be great, wouldn't it? The quality of fucking work you're putting out.
And there we have it guys, I've successfully made myself a pair of matched V Blocks.
No, you haven't demonstrated that they're matched. I'm almost certain that they are not matched. That's the problem. You've spent an awful lot of time setting up cameras, moving stuff around, setting up cameras, moving stuff around, setting up cameras, make a cut, set up cameras, make a cut. If you spent half as much time paying attention to what you were doing as you did to actually doing the work... No, hang on. Yeah, if you spent half as much time as you spend setting up the camera doing the work, you'd produce something that was halfway decent. This is a second apprentice project making V blocks, except that an apprentice would be expected to make them with a hacksaw and a file. And they would be expected to be within a thou or so in all dimensions, and they would be a matched pair, and they would be expected to be matched to an acceptable level of precision. I don't see any indication that you've actually measured anything, really. That's just fucking gash, mate. That's gash. Look at the state of that. Nasty. Anyway, there you go. That's this twat. Maybe I'll do him again. I might do the next episode of this because that looks like it's going to be fucking hilarious as well. But for the moment, that's me done. Peace out. Night.